All right, a video on interpreting reaction diagrams given some information about the potential energy surface. And when I say potential energy surface, I just mean what path do we take from the reactants to the products. All right, so it says in this question, which reaction diagram represents an endothermic reaction, which consumes 20 kilojoules per mole and has an activation energy of 50 kilojoules per mole. Okay, so we have to be able to interpret delta E being positive 20 and EA being positive 50. All right, so you could go about this, you could draw it yourself first and then and then see which one is similar to the graph that you drew, or you could just assess each one. Let's go by assessing each one. So in this first option here, EA is 50, right? Because EA is from reactants up to transition state. That's labeled as 50. That is correct. Our problem here is that this number is showing an exothermic reaction. Okay, so that 20 kilojoules is showing us that the products are lower. And sometimes on these diagrams, you might actually see that as that number might have been written as negative 20 kilojoules. And so that would also have given you the tip off, like that's not right. And I probably should have written that as 20 on here. But it's very clear that it's not an endothermic reaction because our products are lower. So at the end of the day, when we do this reaction going from those reactants to those products, we have to release 20 kilojoules. That's not being consumed by the reaction. All right, the next one here, the EA is actually that 20 kilojoules, and we have an exothermic reaction of 50 kilojoules, so neither of these numbers is correctly labeled, which means that it must be this last option here. All right, so reactants, products, there's our transition state, that's 50 kilojoules above the reactants. That's going to determine how fast this goes, right? Because K, our rate constant, depends on our frequency factor e to the negative EA divided by RT. That is the activation energy. When that number gets big, then K gets smaller. Okay, so when we have a big negative number up there, that means we're making this term even smaller, which means that this is going to be smaller, which relates back to a slower rate of reaction. Okay, and then also this correctly labels that our products are higher in energy than our reactants. And so to make this thing go overall, we have to consume 20 kilojoules of energy. Okay, so if you're holding this, you might feel your flask get a little bit colder because some of the thermal energy is being converted to potential energy to drive this reaction from reactants to products. So this last one here is the right answer.